Okay, let's start. Am I audible?
Yes, sir.
Yes, sir.
Okay. So in previous class, we had discussed the basics thermodynamical properties and the basic two law, that is the zeroth law of thermodynamics and the first law of thermodynamics. And the consequence of the zeroth law is basically is the temperature, and the consequence of the first law of thermodynamics is the basically energy or heat. Okay, but the first law does not tells us that the conditions and limitations of such kind of energy or heat. Okay, so basically the first law of thermodynamics tells the energy of the universe remains constant, but it could not tells that the limitations or how the energy are transformed to heat, or how the energy, how the heat transformed to energy, they could not say that. So there is another law is appeared, that is the second law of thermodynamics. So this second law of thermodynamics is basically a statement which is the Kelvin and Planck statement. And what is the statement? It says that it is impossible for a self-acting device or machine unaided by an external agency to convert heat from a cold body to a hot body, or heat cannot flow spontaneously from a cold body to hot body. Okay, that means any process which violates Kelvin-Planck's statements also violate Clausius statements. Clausius statements is similar kind of statement, that is the Kelvin and Planck's statements. So any process which violates Kelvin-Planck statements and Clausius statements would also violate the principle of increase in entropy. So the question is arise, what is entropy? So I will discuss later what is entropy. So basically the first law of thermodynamics says that basically this is the transformations of heat to energy, or transformation to energy to heat, but it could not say that how to transform, right? So the second law tells that say how to transform, how to, it's clearly say that without without any external agency we could not transform from a cold body to heat, from a cold body to hot body. Okay, that means the heat cannot be flow spontaneously without any external agency. But if we add some external agency or some external work, then it is possible to done from heat to done heat from transform from a cold body to hot body. That means heat can be flow spontaneously from a cold body to hot body only for even they added some external agency. Okay, and the consequence of the second law of thermodynamics, that means the Kelvin Planck statement, is the entropy. And this is the condition delta S, that means the entropy, changes of the entropy or total entropy of the universe must be greater than equal to zero. Del S equal to zero for a reversible process, and del S greater than zero for an irreversible or natural process. And this is the entropy equation, basically how to relate the heat and temperature to entropy. This is entropy, ds, change in the entropy, equal to dq, amount of changes of the temperature, amount of the changes of the heat by temperature. This is the mathematical form of the second law of thermodynamics, and also it is the expression of the entropy related to the heat and the temperature. Okay, so what is the meaning that the delta S universe greater than equal to zero? Entropy is basically the disorderness of the systems. Okay, so entropy measures the disorder of the systems. So the entropy of the universe always increase or remains same. Either it is same or always increase, but does not it decreases. That is greater than equal to zero. Okay. So this is say that the entropy of an isolated system can never decrease. Entropy of the system measure the disorder of the system. So this is the basically the second law of thermodynamics. So what tells the first law of the thermodynamics? That is the basically the transformation of the heat to energy, or transformation from the free energy to heat. But how to transform, they does not tells that. But the second law of thermodynamics basically tells that. Okay. And the consequence of the second law of thermodynamics, that means the Kelvin Planck statement, is basically the entropy. Uh, so, what is the consequence of the second law of thermodynamics? Anybody? Hello? Hello?
Yes, sir.
I'm audible? Hello?
Yes,
Okay. What is the consequence of the second law of thermodynamics? You know that the consequence of the zeroth law of the thermodynamics is the temperature, and the consequence of the first law of thermodynamics is basically the heat or energy. And what is the consequence of the second law of the thermodynamics?
Entropy.
Exactly. So what is entropy? You understand?
Entropy is randomness. That means um,
Yes, randomness of the molecule or
molecule.
randomness of the atom, or disorder. Basically, this is the disorder of the system. Okay, here it is say that the entropy of the system measures the disorder of the system. Okay, that's why the entropy of the universe could not be decreases. It either increases or it remain the same. Okay,
Yes, sir.
okay. Then
Sir,
there is another. Yes, yes,
sir, you said in second law, there
yes.
we need a
External agency. Yes,
external
yes.
agency to transfer heat from hot body
Right,
to cool
right.
body. So how the heat come from sun to earth in vacuum, throughout the vacuum?
Okay. First of all, it is easily transformed from a hot body to cold body. Heat easily transformed from a hot body to cold body. Okay, there is no need to external agency. First of, you
Yes,
have to clear that. Okay,
yes, yes.
but whenever you transform a heat from a hot body to cold body, then you can transform.
Okay.
Right, then
Okay.
you must have need to some agency. But whenever we're talking about the sun to earth, then sun is the hot body and earth is the cold body, so easily transform. So and heat cannot be transformed through the vacuum. Basically in sun to earth, they could not transform basically heat, they transform the light. Okay, okay. Because there must be a medium that need to transform some kind of heat. Heat cannot be transformed through the through the vacuum medium. Okay, there is another theorem, that is the Carnot theorem, and this theorem is very important in thermodynamics. And there is a two statement. First statement is that all the reversible engine working between the source and sink have the same efficiency whatever the working substance. This is the very important concept. All the reversible engine working between source and sink have the same efficiency whatever the working substance. Okay, that means er1 equal to er2. Second statement, er1 equal to er2, basically the efficiency to different substances. Okay, and second law of the second law Carnot statement is that Irreversible engine working between the source and sink can never be more efficient than the reversible engine working between the same source and sink. It is basically than, okay, THAN. That means ER1 equal to ER2. This is basically the efficiency between two different substances in a reversible engine greater than equal to E1. That means the efficiency in irreversible engine. Okay. So this is the two statement in Carnot theorem. So there is another consequences arise. The complete conversion of work into heat is possible, but reverse is not possible. It kind of consequence that is the conversion of work into heat is possible, but the conversion, complete conversion of heat to work does not possible. This is the consequence basically. So on the basis of the Carnot theorem, there is a engine is derived, that is the heat engine, and this engine basically three part of the engine: source, sinks, and working substance. Basically, this kind of engines. This is basically source. That source is T1 and T1 temperature, and this heat provided. This is the Q1, and sinks which have a temperature T2, and this amount of heat is basically Q2, and working substance, that means the some kind of agency here. So those as the working substance, basically how amount of work doing by these substances is basically Q1 minus Q2, because of the amount of heat in the source is Q1, and the amount of heat in the so is seeing Q2. So the work done, basically the difference between the heat, that means the heat work done is given Q1 minus Q2, and the efficiency of the heat engine is basically the work done of the substances and by the heat in the sources. So this is basically Q1 minus Q2 by Q1 equal to 1 minus Q2 by Q1. This is the very important expressions. So here it is seen that the eta equal to 1 when Q2 equal to 0. That means sinks is absolute 0, which is not possible, right? Because of there is no kind of engine which have the 100% efficiency in the universe. Okay, there is any kind of engine does not exist which have a efficiency 100% or eta equal to 1. Okay, that's why the absolute 0 is not possible. So this is the basically the heat engine. Heat engine is basically the which law follow to working principle, basically the Carnot theorem, and there is a three part basically: source, sinks, and source, working substance, and sinks, and the efficiency of the heat engine is basically 1 minus Q2 by Q1. Okay, if you want to details, then go through the book. Okay, any kind of book, Patria, heat and thermodynamics, Patria, then heat and thermodynamics, Reef, any kind of book. But in your syllabus, there is a derivation is not there. Just the expressions, and there is a kind of some mathematics is here.
Sir, which book is better?
You can read Patria, heat and thermodynamics or thermal physics, Patria. Okay, there is another kind of engine which is follow the Carnot theorem. This is a reversible engine, and there is a fourth part of the reversible engine. That is the constructions of the reversible engine. Basically, this is the four constructions. That is the cylindrical with perfectly heat insulating wall but perfectly conducting base and close with a tight fitting, perfectly insulating and frictionless piston filled with a mass of perfect gas and working substance, and a hot body of infinitely large heat capability at a constant temperature T on. That means the source, that is the sinks there, and there is a working substance is basically the perfect gas and perfectly heat insulating stand. So how amount of Q heat, Q1 is basically the sources heat, and Q2 basically the sinks heat. So Q1 is basically the heat taken from the source during the process AB. That means there is a basic diagram, that is the, suppose you have to work this kind of way, right? Suppose you are here and you going through this way B, then going through this way C, and going through D, and again going through A, back to the A. Okay, so how amount of work during this process, this is basically four work done is done. That is mean whenever you go from A to B, the changes between P1, V1 and T1, this is changes to point B, P2, V2 and T1. That means temperature is same, but pressure and volume changes. Okay, this kind of expansion by kind of phenomena is known as the isothermal expansion. Because why it is isothermal? Because of temperature of these two process, 2 point T1 and T1 is same. Whenever the temperature is same, this process is called isothermal expansion. Okay, and how amount of work done during this process, this is basically mu r T1 log V2 by V1, and mu is the mass of the some particle or some atom or some substances. Okay, this is basically mass, and r is the universal constants, and T on the temperature, and V2 to volume is basically V2 V1 is a volume. So this is the basically isothermal expansion. Whenever you go from point B to C, you look at P2 V2 T1 and P3 V3 T3. So there is a changes, pressure, volume, and also temperature. So this is the basic. Whenever temperature are changes, this is not basically isothermal expansion. This kind of expansion is called adiabatic expansion. Okay, and how amount of work done during this process? Basically, this. You look at this. This is basically same expressions. This is the similar expression before, right?
So what is mu?
Yes.
What is mu, sir?
Mu is basically mass of the system or mass of the particle or mass of the,
Okay.
you have to provide mu. Okay, so basically this is the mass of some things.
Okay.
And whenever you go through go from the point C to D, you look at the, this is the basically opposite case to the A to B, right? So this is basically the isothermal compressions, and the expression of the isothermal compression is basically CD. That's basically, this is the similar expression, that's why. And whenever you go from D to A, basically this is the opposite expression of the B to C, right? This is, that means the adiabatic compression. So this is the adiabatic expansion. That means the whenever you go from the point B to C, so how amount of work done? Basically this mu r gamma minus 1. You know that gamma is basically the ratio between Cp by Cv, right? And mu r gamma minus 1 T1 minus T2. And this is basically WDA, which is the opposite to the BC. That means mu r gamma minus 1, this or T2 minus T1, or you can write that way. Okay, so this is the basically phasor diagram about a Carnot engine. So whenever
Is
in,
Q2 negative?
yes, whenever you come on
Q2 equals to minus mu r T2. So this is equal
it's
sign.
kind of negative, sign negative, because of
Q2, sir.
according to this expression, because of this is, if you take this is the right expression, then this dA basically the opposite of that opposite of that process, right? Whenever you look at the process D to A, this is the process which is opposite to B to C, right? That's why it is taken as a negative. Look at that. Look at that.
So for this adiabatic
Work done
expansion,
is same. Whenever work done is same, so what is the sign? Then is the opposite sign, that means, right? Hello?
Yes, sir.
Is it clear? Okay. Yes, yes. Hello, hello. Okay, okay. Okay, so this is the efficiency during this work done, A to B, B to C, C to D, and D to A. This is the efficiency basically work done by Q, and this is the basically expressions. And finally, we have reached that expression eta equal to 1 minus T2 by T1. Okay, you know that refrigerator?
Yes, sir.
Example, refrigerator. Can
Sir,
anybody
freeze.
say that?
Freeze.
Yes, freeze. Freeze is basically refrigerator. So freeze is where the basically Carnot theorem, there is a work there, right? So basically what happened in the freeze, basically a refrigerator is a device that remove heat from a cold body and adding it to a hot body with the help of the external agency. Okay, so refrigerator is basically a device that remove the heat from a cold body and adding it to a hot body by or with the help of the external agency. It is the reverse of the heat engines. Basically, heat engine is working as a Carnot theorem, and Carnot theorem states that basically the real phenomena. That means whenever you going through the transformations of heat from a hot body to cold body, right? Because of, if you look at the heat engine, so there is a present source and sinks. So basically the source temperature always greater than the sink temperature. That means this is the transformations of hot body to cold body, right? So this is the real engine. But whenever you're talking about the refrigerator, this is the reverse of the heat engines, because here what happened, this is the basically the transformation of a heat. How to transform the transformation of a heat?
lower to higher.
Basic, yes, lower to higher. That means from cold body to hot body, right? So this is the cold body. That means the temperature T2, and this is the amount of heat Q2, and there is some amount of external agency here arc, and this is the hot body T on, and the temperature T on, and heat Q2. So there is a not efficiency is here, but there is a there is a performance are taken. Okay, so K is the performance, because there is a others process is happens, it also be efficiency, but we does not derive the efficiency. We derive the performance of the refrigerator, or performance of the reverse of the heat engines. So performance is basically written as a K, which is the Q2 by W, Q2 is basically the cold body heat, the amount of heat from cold body, and W equal to basically work done. Basically, there is a temperature difference, or there is a amount of heat difference is here. That means there is a work done sum. Okay, so that's why we have written K equal to Q2 by W equal to Q2 by Q1 minus Q2. So this is basically we write that, and basically we find K equal to T2 by T1 minus T2. Okay, so this is the two expression is here. Basically K, which is the performance of the refrigerator, and eta is the efficiency of the refrigerator or efficiency of the heat engine. So there is a relation between them, eta equal to 1 by k plus 1. This is the relation is basically uh, we will give some mathematic problem, then you have to must remember that. Okay, eta equal to 1 by k plus 1. So this is the basically relations between the performance of the refrigerator and efficiency of the refrigerator. So in the second law of thermodynamics, we have to see that the consequence of the thermodynamics, second law of the thermodynamics is basically the entropy. And what is the entropy? Entropy is basically measure the disorderness of the system or disorder of the molecule, and the mathematical expression of the entropy is given by ds equal to dqr by t. You write that dq by t. Basically dq is the amount of heat changes in the system, and t is
Energy
basically
per
the temp.
temperature.
Yes, hello.
Energy per unit temperature.
Yes, so if you take the integration both side, then it gives delta s is basically integration of I to f, that means initial to final point, and dq by t. Okay, so this is basically the expressions of the entropy. And there is a some kind of word say that you read that. Okay, this is basically the what is the meaning of the entropy, and how to relate the other things. So there is a problem, that mathematical problem, that, and this is the very important problem. So the problem is the mass capital M of a liquid at temperature T1 is mixed with a equal mass of same liquid at temperature T2. The system is thermally insulated. Show that the entropy change of the universe is that. Okay, so this is basically mathematics. Suppose you have two reservoir, then you add to them. So to have two reservoir and add them, so what is the temperature of the mixture or final reservoir is basically T1 plus T2 by 2, right? Basically you have to mix two temperature, T1 and T2, then the temperature, final temperature is given by T1 plus T2. So if you look at the how the temperature changes, basically two temperature T1 and T2. So there is a two temperature changes, T1 to T2 plus T2 by 2, and T2 from first of all you have to change this way, T1 to T1 plus T2 by 2, and another way you have to change T2 to T1 plus T2 by 2, right? That's why the entropy written as delta S1 is basically T1 to T1 plus T2 by 2, and delta S2 is basically the second process or second reservoir, T2 to T1 plus T2 by 2, and the two expression is given. Then the total entropy is basically the summation of two entropy. So this is just a mathematics, then you have to find out this expression, and this is a very important problem. Okay,
एग्जाम में आएगा सर
क्या?
एग्जाम में आएगा सर
जो सैंपल क्वेश्चन है एग्जाम में उसी से क्वेश्चन सेट किया जाएगा. ओके, सो रेडी दिस क्वेश्चन इज वेरी वेल. ओके,
यस सर, ठीक है सर।
I I provide some sample question, right?
यस
Yes,
सर।
sir.
Okay, ready them. Okay, just do it yourself. Okay. So there is some relation that is called the Maxwell's relations, basically the fourth Maxwell relation in thermodynamics, and there is no derivations have to done. Okay, just write down the four Maxwell relations, those relations: first relations, second relations, third relations, and fourth relations. Okay, just the expression. Okay,
So,
basically
derivation is not
basically the
important.
Maxwell relation related the different kind of parameter in thermodynamics, how to changes to each other. This is the relation basically. Okay, how to changes different kind of parameter in thermodynamics. Suppose you have to entropy and you have to provide some amount of pressure, so how to they are related. So this is the relation between the different kinds of parameter in thermodynamic system. That is the relations which is the Maxwell relation. Okay, so only you have to remember that is the final expression. No need to be derived. Okay, just the final write down the expression. Okay. If anybody want to derive, you can
सर
derive that
एक्सप्रेशन समझा
yourself.
दीजिए ना सर, समझ में नहीं आ रहा।
एक्सप्रेशन तुम लोगों का ये जो एक्सप्रेशन है ना, ये तुम लोगों का फर्स्ट ऑफ ऑल जानना पड़ेगा व्हाट इज द पार्शियल डेरिवेटिव.
सर
और दो
Yes, sir. Nargis ma'am has explained us about partial derivative. So you can, yeah, explain that expression, please.
सिर्फ एक्सप्रेशन बता दीजिए सर।
okay. But derivation is not necessary. Okay, basically here it is start from a first law of thermodynamics. What I say that basically the Maxwell relation. What is the Maxwell relation? Basically the relations how to relate the different parameter in thermodynamics. Basically there is a several type of parameter, or there are several type of properties, that is the pressure, temperature, entropy, heat, there is a type of parameters, right? So how they are related? So Maxwell derived the first law from the first law, from the second law, those kind of parameter related them just. So how to relate it? Basically the from the first law of thermodynamics, dq is here, and this is ds, basically the temperature, and you look at the ds is related to the amount of heat, and heat is provide basically the first law of thermodynamics, dq equal to du plus dw, and du basically the amount of heat, or the change of the heat. Okay, and du basically the changes of the internal energy of the system, and dw the changes of the organ. You can say that d means the interval or changes. Okay, so from that two equation, you have found that du equal to tds minus pdv. Just provide this value dq. Dq is here and dq is here. If you equal to equation dq, then you give this, right? And if u is a function of x and y, then it could be written as a delta u by del u del x. Is it clear? This is basically partial derivative. Hello.
Yes, sir.
Is it clear? So whenever we take the second derivative of the internal energy, this written as that way, because internal energy or entropy or volume or pressure, it can be a function of x and y. So whenever a function is contained is say more than one variable, then we take the derivative. This kind of derivative is known as the partial derivative. Okay, so this is basically u, and internal energy is a function of x and y. That's why this is written as that way. And how to write these expressions? So you write that way: del by del y, t del by del x minus p. Basically, this is the technique to relate the one things to another thing. That's it. Okay. Basically, this is the technique how to relate. Maxwell did that. This is the technique. Okay, I am not going to explain these expressions. So there is a fourth Maxwell relations that is delta S by delta V, and at a constant temperature is equal to delta P by delta T at a constant volume. That means at constant temperatures, the amount of uh, entropy with unit volume equal to the amount of pressure with unit temperature at constant volume. So you not does not to need to be explain the Maxwell relations. Just derive these expressions. Just not derive. Just write down the expressions. So there is a four Maxwell relations, and there is a several kind of energy. You know that the two kind of energy, that is the kinetic energy and potential energy, right? But you know in thermodynamics there is another kind of energy, that is the internal energy, right? So there is a several kind of energy exist in a system, that is the Helmholtz free energy, gives free energy. There is a several kind of energy, and how to relate this kind of energy? Basically, F is the Helmholtz free energy. This is the basically thermodynamics energy, or thermodynamical energy is written as U minus Ts. U is the internal energy and T is the temperature, S is the entropy. So whenever you subtract the TDS amount in an internal energy, that energy gives us the Helmholtz energy. And if you take the partial derivative, or the take the supposed derivative, just take the derivative df equal to du minus TDS minus SDT, right? And du from the first law of thermodynamics, that expression, and if put that expression here du, then gives us this minus pdv minus sdt. And whenever you're taking the partial derivative with respect to several, because of there is a v and there is a t, so if you took first or partial derivative with temperature T with respect to V, then the whenever volume constant, that means this term is goes to zero, right? So del F by del T at constant volume gives us minus S, because of dF equal to minus PdV minus SDT. So at constant volume, this term goes to zero. So whenever you dt derivative with respect to derivative this form with respect to t, then gives minus s. Whenever at a constant temperature means dt is zero, right? So whenever you derivative f with respect to v at a constant temperature, then gives the pressures. So this is the related, basically this is the related things that how to relate different parameters. And Helmholtz free energy gives the Maxwell fast relation, basically. There is another kind of terminology is here. That is the enthalpy or the total heat function, and what is expression or how to write down H equal to U plus PV. That means if you add some amount of PV in a internal energy, then it gives as the enthalpy. But whenever you 2ds amount of heat is subtract from the internal energy, that gives the free energy. So basically this is the enthalpy, and how to relate it to the others parameter. Basically you take the derivative ds h equal to du plus pdv plus vdp. Basically take the derivative, and you know that the first Maxwell first relations, then you put this expression and gives us tds plus vdp. So whenever you take the derivative with respect to s at a constant pressure, that means pressure is constant, that means dp is 0, so this term is goes to 0. Then basically this arises as a t, and whenever you take the derivative at a constant entropy, then gives the v. So there is a related, how to relate a temperature, how to relate it v in different parameter. Okay, and this is gives the basically the Maxwell fourth relations. And there is another kind of energy is there. This is the Gibbs free energy, and Gibbs free energy is basically the U plus PdV minus TdS. Okay, so if you add some amount of heat, add some amount of PdV and subtract them TdS, then the internal energy gives basically the Gibbs free energy, right? And if you take the derivative both side, so this expression is given as that basically dg equal to du. Basically this is the derivative form, so this is given as vdp minus tds.
Bad habits.
So if
The master study the habits of.
hello,
স্যার বলছি যে আমাদের 11টা থেকে ক্লাস আছে।
ঠিক আছে, আমি 11টার মধ্যে শেষ করে দেবো। কেউ কিছু কি বললো তোমাদের মধ্যে? হ্যালো হ্যালো,
না স্যার আপনি
Okay.
কন্টিনিউ করুন। ওর মনে হয় মাইকটা স্যার অন আছে বলে এটা।
Okay, so this is basically the volume and how to relate the entropy. This is the basically Gibbs function or Gibbs free energy. So you know that there is a behind the kinetic energy and potential energy in a system, there is a several type of energy exist, right? It have to be a Gibbs free energy, it have to be enthalpy, it have to be a Helmholtz free energy. So suppose someone have to provide a system that does not mean the energy that does not mean the energy have to the only the potential energy or kinetic energy. Okay, there is a several kind of energy exist, especially whenever you talking about the thermodynamical system or thermodynamic system or view whenever you view from a thermodynamic frame, then there is beside the potential energy and kinetic energy, there is a several kind of energy exist. Okay, this is basically energy which is the related to the different parameter of the thermodynamic systems, temperature, pressures, heat, entropy. This is, and this is the physical significance of Helmholtz free energy. And basically, you take the derivative and what comes the derivative is right that. Okay, anybody, any questions?
Sir, can you explain the difference between CP and CB?
What I explain, CP minus CB?
No, sir. What is CP and what is CB?
Yes, CP is basically what is CP? Whenever you find out a specific heat at a constant pressure, right? Then it is written as a CB. Basically, CP, CB, it's a specific heat. And what is specific heat? Anybody? Specific heat is basically the requirement or amount of a heat that required to changes a system to increase some amount of temperature. Okay, if you change the temperature of a system, then you have to need some amount of heat, right? Otherwise you could not change the temperature, right?
Sir, specific heat, it means the you if there is a unit mass which we want to increase temperature 1 degree Celsius or 1 Kelvin, we for that we need what amount of heat that is the specific heat.
That is tells you, if you change the temperature, so there need to be some amount of heat, right? So this is the specific heat.
Yes, sir.
It could be a 1 gram, it could be a 2 gram, it could be a 3 gram. This is the basic definition.
Yes,
Standard way you say that this is the 1 gram. But the basic thing is that whenever you change the temperature of a system, then you must have need some amount of heat. So the amount of heat to need or requirement to changes the temperature is basically the specific heat. Okay. It could be a 1 gram, 2 gram, 3 gram. This is a standard form, basically 1 gram. That's why I written 1 gram. তোমরা সবাই কি ওই কোশ্চেন গুলো রেডি করছো তো?
yes, sir. Yes.
হ্যাঁ স্যার। স্যার
হ্যাঁ বলো।
হ্যাঁ স্যার, আপনি সেকেন্ড দিন যে সেটটা দিলেন তার ফার্স্ট কোশ্চেনটা স্যার একটু যদি বলে দিতেন স্যার, মানে হচ্ছিল না আর কি। সেকেন্ড সেটে ফার্স্ট কোশ্চেনটা
কি ছিল সেটা?
দাঁড়ান স্যার এক সেকেন্ড। Sir, the internal energy of n moles of a gas is given by E is
ওকে,
equal to
যাদের যাদের
3.
ক্লাস আছে তারা বেরিয়ে যেতে পারো, আমি আর নতুন করে কিছু পড়াবো না আপাতত। তোমাদের আপাতত থার্মোডাইনামিক্স এন্ড হিট আপাতত আমি আর কিছু পড়াবো না। তোমাদের পরবর্তী যে পড়াটা পড়াবো সেটা হচ্ছে মডার্ন ফিজিক্স বলে একটা পার্ট আছে, কিছুটা পড়াবো, দেন তোমাদের এক্সাম কাছে আসছে। এক্সাম কবে?
20th of March.
20th of March. Okay, I will take maximums 2 or 3 classes. Okay, more.
Okay.
আসলে আজকে অনেকজন জয়েন হতে পারেনি, মানে 100 জন হয়তো এখানে, তারা কি করবে?
দেখো এইটা না অ্যাকচুয়ালি ভীষণই প্যানিক দেয়। অ্যাকচুয়ালি আমি তোমাদের একটা কথা শেয়ার করি, টোটাল 5টা ডিপার্টমেন্টকে একজনের উপরে ডিপার্টমেন্ট প্রোভাইড করে দিয়েছে, ছেড়ে দিয়েছে সমস্ত কিছু। এটা পসিবল না, মানে এটা অনলাইন বলেই সম্ভব। যদি এটা অফলাইন হতো, তোমরা ভেবে দেখো যে 250 জনের ক্লাস কিভাবে পসিবল হতো। 250 স্টুডেন্টস একই ক্লাসে পড়ানো যেত সেটা? এটা পসিবলই নয় অ্যাকচুয়ালি। একটা সিস্টেম এগোচ্ছে, সিস্টেমে কিছু কি বলবো, মানে কোনো ঠিক নেই, যাকে যেমন করে পেরেছে দিয়ে দিয়েছে। প্রবলেমটা ফেস করতে হবে বেসিক্যালি তোমাদের। তোমাদের কথা তো সেরকম করে কেউ ভাববে না যে কি করছো না করছো, তো প্রবলেম তোমাদেরই ফেস করতে হবে। সেই জন্য আমি কতটুকু পড়াতে পারছি বা কতটুকু দেখাতে পারছি সেটা ইম্পর্টেন্ট নয়। তোমরা মোটামুটি এই নোটগুলো স্টাডি করো, আর এক্সাম নিয়ে একদম অতটা ঘাবড়ে যাওয়ার কিছু নেই, কারণ তোমরা ফার্স্ট এক্সাম দিচ্ছে আজ ইউনিভার্সিটিতে। সেই জন্য আমি কিছু স্যাম্পল কোয়েশ্চেন্স প্রোভাইড করছি, যাতে করে তোমরা সেইগুলো পড়াশোনা করে একটা মার্কস ভালো পেতে পারো। ঠিক আছে, তো সেইগুলো ভালো করে পড়ো। অ্যাটেন্ডেন্স নিয়ে কোনো চাপের কারণ নেই।
ওকে স্যার।
স্যার আমার একটা কথা।
কিন্তু তো বেসিক্যালি ইঞ্জিনিয়ারিং ফিজিক্স তোমাদের ততটা ইম্পর্টেন্ট নয়। বেসিক্যালি তোমাদের থিওরেম গুলো পরবর্তীকালে বিভিন্ন এক্সপ্রেশনে কাজে দেয়, বাট তোমরা তোমাদের সাবজেক্ট গুলো ভালো করে পড়াশোনা করো। হ্যাঁ, তোমাদের যে মেজর সাবজেক্ট রয়েছে ইঞ্জিনিয়ারিং ফিজিক্সের, সেইগুলোকে একটু ভালো করে পড়াশোনা করো, নাহলে প্রবলেম কিন্তু তোমরাই ফেস করবে। মানে ইউনিভার্সিটি অথরিটি ফেস করবে না, কোনো স্যার ফেস করবে না, কেউ কোনো কথা শুনবে না, প্রবলেম তোমাদেরই ফেস করতে হবে। সো একটু ভালো করে মনোযোগ দিয়ে তোমরা তোমাদের মেজর সাবজেক্ট গুলোকে একটু ভালো করে জেনে নাও। নাহলে কিন্তু তোমরা হঠাৎ করে যখন ক্লাস খুলে যাবে দেখবে সেকেন্ড ইয়ারে উঠে গিয়েছো, দেখছো অনেক কিছু পারছো না, তোমাদের প্রবলেম ফেস করতে হবে। সো মেজর সাবজেক্ট পেপার যেগুলো রয়েছে, মেজর পেপার, সেগুলো ভালো করে স্টাডি করো ডিটেলসে, কারণ আলটিমেটলি তোমাদের নিজেদেরকে পড়াশোনা করে একটা জব হাসিল করতে হবে কিন্তু, হ্যাঁ, আদারওয়াইজ কেউ তোমাকে কোন রকমের হেল্প
सर
করবে না।
हिंदी में बोलिए सर।
হিন্দি।
চলো ঠিক আছে, যে বাংলা বোঝে তার থেকে জেনে নেবে, যে বুঝতে পারছো না।
স্যার
আচ্ছা,
একটা
কে কি
কথা ছিল।
বলছিলে বলো।
হ্যাঁ স্যার, আমি তো আজকে ফার্স্ট ক্লাসে, আমি অনেক পরে ভর্তি হয়েছি, আমি বাংলাদেশ থেকে এসেছি। সুতরাং স্যার আমি এই যে প্রিভিয়াস ক্লাসের নোটগুলো পাইনি, বা আমি তো ওই ক্লাসগুলো পাইনি, এখন ওইগুলো আমি কোথা থেকে কালেক্ট করতে পারি?
আচ্ছা, গুগল ক্লাসরুমে ক্লাসগুলো মানে পাওয়া যাচ্ছে না, নোটগুলো?
হ্যাঁ স্যার, সমস্ত গুগল
হ্যাঁ
ক্লাসরুমে
স্যার,
আছে।
পাওয়া যাবে।
হ্যাঁ, তা কেউ একজন ই করে শেয়ার করে দিয়ে, তো গ্রুপে শেয়ার করেছিলে তো মনে হয় তোমাদের মধ্যে কেউ কেউ।
স্যার এর আগে স্যার কতগুলো ক্লাস হয়েছে স্যার?
বেশি ক্লাস হয় না, আমি সেরকম তোমাদেরকে আমি নিজে মানে এটা কি বলবো, আমি স্বীকার করে নিচ্ছি, আমি তোমাদের সেরকম কিছুই পড়াতে পারছি না, আর কিছু ক্লাসও নিতে পারছি না। আমি জাস্ট কিছু জিনিস তোমাদের বলে দিচ্ছি, প্রোভাইড করে দিচ্ছি, তোমরা নিজেরা করো, নিজেরা পড়ো, ব্যাস এইটুকু। আমি তোমাদের অ্যাজ এ গাইড করতে পারি যে হ্যাঁ, তোমার হয়তো কোনো জায়গায় প্রবলেম হলো, তুমি সেটা বললে আমি তোমাকে বলে দিতে পারি এই বুকটা